right, let's get going. Hello, everybody. Good morning, good evening, good afternoon, wherever you are. Thanks for joining. My name is Dan Gordon. I am a platform engineering product leader here at Harness. Thank you for joining this session. We're going to talk about developer freedom and the compliance that can still happen with that so that our platform engineering team is happy as well. And we're going to do that through environment management. So welcome, thanks for joining. A few logistics before we get going. As mentioned in the chat, if you have some comments, please do put them in the chat. I'll do my best to keep an eye on it and get back to you or answer questions. As well as if you have questions, put them into the question, the Q&A on the side, and towards the end we will have a discussion or look at those questions and answer as many as we can. Anything that we can't get to, we will answer outside of this time. Anyways, thank you very much for joining, and let's get going. So first thing is to get everyone kind of warmed up, let's get going with the poll. And hopefully as we go through this content, you'll see where these questions, where these options make more and more sense. So if you could please, poll should be popping up, or it's on the right side of your application. Please give us some knowledge. Which of the following tools are you using in your SDLC? Are you using an internal developer portal only, as in not infrastructure as code as well? Or are you using infrastructure as code? Are you using both or using neither? We'll give that a few moments. Let's see where we end up there. And as I mentioned, hopefully as we go through this, it'll be more and more obvious why I'm asking this question. Didn't want to stick it at the end though. Okay, so it looks like a lot of people are using infrastructure as code. That's not surprising. I think that's become pretty mainstream. We're going to talk about how that alone is not quite enough, and what the next step beyond that is. Thank you for that, for the poll input. Let's move on. So let's start kind of at the beginning, just to make sure we're all, have the same context as the starting point. A while ago, developers developed on their laptop, actually it still happens, or their desktop. And when they were ready, it went to production. Now, that is how it used to be a long time ago when we didn't know any better. And that caused problems, as we all know, right? That led to the rise of many different software development methodologies and delivery methodologies. This was a problem because we didn't have a way to validate, and the developer's laptop was entirely differently configured than the production environment. And this is, of course, back in the Yahoo days, where, like, you were Macho Man if you went to prod straight. Then we got smart and we said, well, actually, we need a testing environment between what the developers do and when we're in production. We already have this separation. There's different owners. There's people that want different things. We'll talk about that more. But we got in the QA environment. And the QA environment helped because it gave us a stopping point to validate how well the code worked before we got it into production. But there was a problem, which is that the QA environment and the production environment oftentimes didn't match, even to the best of our attempts. And what that led to was this false notion that things looked good and we should push it to production, and then ensued war rooms and mass chaos and panicking as what we thought was working in QA failed in production. And unit test environments and integration environments, and it just goes on, pre-QA, staging, UAT, performance, canary, so we can be careful and roll out a little bit at a time, even PR environments, right? And the point is, there's a need for lots of environments, and those have grown. And we've kind of ended up with this mess now, right? We have lots of environments to serve different purposes for, across the different delivery cycle. And different owners of those environments, and you can guarantee that they're not all matching each other, and there's a lot of resources out there that are getting wasted, and therein lies the problem. And the players that are kind of on different sides of this, I'm going to bring those up here just so we have this as a grounding. We've got the software development team that we're talking about, the developers, the QA engineers, they have their environments. We've got the platform teams, what we'll call them, and that's kind of, DevOps and platform team has kind of evolved into platform engineering, but this could be anybody, like just a DevOps team or the cloud team, the SRE team, the security team. They're all focused on that other part, the non-development or the production piece of it. And so the first problem we have is one of tug of war, right? We have the development teams that need speed, autonomy, realistic environments so that they can build and test code and be confident that what they've built and test is actually working when they put it into production. We've got the platform team that needs to enforce standards and control the infrastructure so that they can have stability, security, and cost efficiency. Now, I'm not telling you guys anything new that you probably don't already, haven't already experienced or know about, but you might be thinking, yeah, this was before DevOps came along. And the reality is this is still the case because DevOps was great. I've been a big part of that movement and making products for that and being part of, helping teams migrate to that, evolve to that. But it's evolving into platform engineering. And what we found is that even though we said everyone, you're on the same team, people still had different roles and different needs and different responsibilities, even though they were going for the same goal. And even today, we have many an environment, many a customer, many organizations that do software where this dichotomy still exists. And you have to ask yourself why. We've become so much more advanced, right? We have infrastructure as code. We have tracking of our software. We have, Git. We've got the ability to be, to automate our processes. But the reality is a lot of these types of processes are still steeped in the traditional ticket-based model, and that puts these essential goals in direct conflict. It's creating bottlenecks and frustration for everybody. So basically, the system is broken. It's still broken, and we need to take that next step, the next evolution. We need to do more than just auto-configure the infrastructure or just make sure we have or know which version of the software is out there, right? They need to go together. But another piece of the problem is that kind of comes from that dichotomy, from that pulling, tug of war, is the snowflake problem, right? We had snowflakes before, systems that were all manually configured. We thought we solved it when we automated the process of configuring systems and we could just stamp it out and have everything done exactly the same way. But there was process and dependencies and so much more around that did get taken care of the first time. And so snowflakes still exist. They're snowflake environments. They're uniquely configured still. They're a symptom of this tug of war between development and platform engineering, because what's going to happen is if a developer needs to get something out the door or needs to get something tested and they can't wait anymore for the process to go through to actually create an environment, they do it themselves. You have shadow IT, right? They might have the need to actually create an environment that's a copy production, but not being able to. And so they make the tweaks, and then they have something that's not quite production, and they're testing on it. It's a snowflake. And this leads to a lot of the problems that we're trying to solve for, right? We get cost overruns from resources that get wasted because we spin off an extra environment to do some testing that maybe is large or maybe small, but we forget about it, maybe a PR environment, and it becomes zombie infrastructure. Security and compliance gaps are a problem. Because we end up with non-standard environments created from manual work or undocumented configurations, or that were defined properly and then changed to meet a need. right? Of course, this leads to a degraded developer experience because our development team now is still frustrated trying to get their new code tested and ready and out to production. Their innovation is getting stifled. They can't test as readily as they want, and this causes delays in the ability to get to deliver value. This leads to problems with scale, right? If everything's a snowflake, how do you manage them appropriately? Do you even know about them, right? And microservices and cloud native apps have made this worse because now we have so many more systems, so much more interdependence that managing it manually is impossible. And this leads to bugs and incidents, of course, right? If we have misconfigurations, I might test an environment that I think is configured properly, and it turns out it's not. And when I go to the next environment, possibly production, we have a problem then that shows up. And then the troubleshooting is hard. The capabilities that we're trying to ship get blocked, and we basically end up with higher change failure rates, more required rework. This slows our lead time to change and our ability to deploy frequently. And if those sound familiar to you, they should, because that's DORA, right? This affects our ability to do well with getting our software delivered. There's also another challenge, which is the day 2 operations nightmare, and this is actually one of the big ones as well. If we think about this process of provisioning an environment, great, it's provisioned, that's the start, right? We've automated it and maybe even tracked what's in there. What about the next change and the next change and the need to make those changes? If we can quickly get an environment to a development team and say, go do what you need, but then they have to turn around and put a ticket in and wait when they have to ask for a certain access or configuration change, or to upgrade a library, then getting it out fast does not help, right? So creation is important to automate, but day 2 operations is equally, if not more important. The ongoing lifecycle management of an environment is critically important. So how do you do things like add a disk or modify a security group, update and track the software versions that are on your environments, make sure that infrastructure that's no longer needed is properly and cleanly decommissioned, and prevent these environments from drifting in configuration over time. Yes, it started compliant and now it's not anymore and we don't even know it, right? These are challenges at day 2. And without a streamlined process and a tool that can help with that to pull it all together, the answer is often more tickets, more manual work, and the uncontrolled growth of snowflake environments, which we want to avoid. So what is environment management? Environment management, really, it's usually termed as self-service environment management. That's actually a key phrase, but we're kind of being short on it. Everything should be self-service. But self-service environment management provides a standard, secure, and easy way for developers and platform engineers to create, discover, and manage and consume the environments. It can be used for creating and managing just infrastructure, because that's part of an environment, or infrastructure plus apps, which is where you get a bigger value, because now it's not just what it's running on, but what is running on it, the bigger picture. And environments in this case can be long running. For example, staging, production, maybe a UAT environment, or it can be ephemeral. Could be a developer testing environment, like one per developer, or a group testing environment, or tied to an epic, right, or a story, or even a PR environment, which goes, gets spun up and then thrown out as soon as the PR is cleared. So let's talk about some key concepts. Okay, so first and foremost, key concept to think about, to understand, is what we call environment blueprints. This is the notion of defining how an environment looks. There's more to it than just a Terraform or a Helm chart. These are dynamic. They're not just templates where we replace information. There are, however, workspace templates as part of them. Think of environment blueprints as an executable contract, not a static template. And it's important to have this definition, not just of how pieces come together, given different configurations, but also how do you manage the life cycle, the day two piece of it that needs to be defined as well. So this includes workspace templates, like as in, for example, like from Terraform or infrastructure as code management. Catalog components from your software catalog and your IDP that defines your services and your software and your APIs. Configurations coming from both the platform engineer who set this up and the development team who has some defined definitions of what they need to have. And so the combination of those, the blueprint is going to define where changes can be made and what changes are acceptable. Workflows that, as I mentioned, define the behavior about day two, about creation, about management of the system, about how to destroy it, etc. And then very importantly, environment blueprints include environment blueprints. Yes, these are composable. It's a very key aspect where you can have Lego blocks, basically, or blocks that you can build pieces together and have bigger systems. So that's the environment blueprint. Those are stored in your internal developer portal. And when they're executed, they go to a platform orchestrator. Platform orchestrator is going to use intelligence and look at all of the pieces and figure out what needs to be configured based on where it's going and what pieces are coming with it and what it's being put together with and what the dependencies are, so it understands what order things need to be deployed in. And then those end up creating environments. So environments are the collection of software components and infrastructure resources. That's the whole package, the running instance. Now, over on environment management, or environments rather, on each environment is the definition of how do you pause, how do you resume, how do you update and delete these environments. In other words, how do we handle the environment throughout its life cycle? Important if you want to be able to continue to make easy the use of the environment. For example, a developer that has a small change that they made and they need to get it out to that environment. Should we make them rebuild the entire environment? Probably not. Do we need to make sure that that change is tracked? Absolutely. So we don't want those snowflake environments. Also, I might have environments that I need at certain times when I'm doing certain types of testing, for example, and I don't need to have it running because that's costly. The ability to pause environments and then resume them. And then, of course, very importantly, the ability to track and delete. Deleting an environment, that can in itself be complex because you may have, you don't want to leave dangling uncleaned connections and dependencies. But the other part of it is that you have to be able to find the environment and know what deleting it means. And there's drift. Right? Drift is very important. Just like when we look at something like infrastructure as code management, Terraform Cloud, for example, or enterprise, right? The need to be able to make sure that our environment matches what we defined in the blueprint. And in this case, it's at all the levels, not just infrastructure as code levels. And so that's important because when we have drift and we don't know it, then we end up with, again, with those snowflake environments, with environments that we think we're testing or using appropriately that don't lead us to where we want to be. And then the software catalog. This needs to be part of the developer platform. It's critical because these changes are going to be made. Resources will be created. Systems, applications are going to be set up. Services are going to be used. And we need all that information to be captured so that we have a graph of what's related to what in our software ecosystem, so that when developers are developing and operations are operationing, are doing their job, and when everyone's doing what they need to do, they have access to the information about the state of the environment, and importantly, all of the meta information that helps them to be efficient whether that's for coding or for doing incident response or for or for doing the right amount of testing. And really having this all in one place enables the IDP to be much more of a better tool for an improved developer experience, so that the work as developers are working, they don't have to go context switch to different tools to go find out the information or ask around to find out who owns or knows about XYZ that they're now reliant on, or maybe that they're using. So the other part that's important is that governance we talked about, built-in guardrails. And the reason those are needed is because we're trying to enable freedom and autonomy for our developers, and we can't really do that. Well, we can do that one of two ways. We can either say, go do what you want, we've been there, that doesn't work, or we can give them the freedom with the guardrails that ensure compliance to our standards and our requirements and our security needs. So environment management is a very powerful toolkit because it starts at the creation of the environment and then manages the environment as it goes through its life cycle. And every step of that way, we're able to insert policy and compliance checking to make sure that we don't, buy the most expensive, cloud resources, or use more that buy more than we're actually using, or make a security setting that is insecure, or provision too much, too much disk space, or whatever your organization needs to guard. These are all things that we want to be able to do. The mechanisms that enable that, we already talked about drift detection. This is important to actively monitor and flag environments that are deviating from the blueprint, because the blueprint is a definition, including the policy, of how we want things to be and of what's okay. Policy is code, whether you're using OPA or something else. This codifies and enforces the security cost compliance rules, for example, and they're enacted at provisioning process, as I mentioned earlier, as well as throughout the lifecycle changes. And then role-based access control is very critical at multiple levels, so we can ensure that developers have the access that they need, but only the access that they need to modify environments and the types of code that they're putting out. We need to make sure that for their role, they can get to and modify the environments that match their role, but not the others, or their team, or their organization. So really, environment management gives us kind of a win-win, a dual value for both the software development team, who can get velocity and autonomy, and the platform engineering team, or platform teams, who can get control and governance that they need. Right, from the software development side, we are able to reduce their cognitive load because we're abstracting away all the complexities of dealing with the environment systems, right? Most developers want to write code and solve problems, not set up Kubernetes, right? Or figure out how to set the network, and the security pieces up. This is going to eliminate their wait times because they have on-demand environments. They can self-serve and get what they need in minutes, rather than having a ticket ops back and forth for days or even weeks before they can move forward with that simple test that they need to do, for example, just to see which direction they head next, right? Or bigger, right? It might be a bigger need from that, and they might still be stuck up against deadlines. And then shift left with confidence. What does that mean? If we shift left, and people get tired of that term, but the notion of being able to test as early as possible, where it makes sense, and do that with an environment that that your results are valid once you get all the way to the right in production. If you're testing, like in the beginning of this presentation, if you're testing on your laptop, and you know that it's nothing like your production environment, or you're testing on your, the next test environment you have available. Maybe it's just a pre-QA or QA environment, and it's nothing like your production environment, or there's, even if it's close but it's not the same, how much confidence that do you have that your results are actually valid, right? The ability to get fresh production-like environments, potentially for every PR, right, or change, is highly valuable, because that means that when you get a good result, it is a good result in the testing. On the other side, the platform engineering team, right, they don't have to be the bottleneck anymore. They don't have to be the guys that say, wait, stop, right? They can be an enabler. Blueprints give them the opportunity, give our platform engineering team, gives them the opportunity to capture the way things should be, to capture the processes the way that they should be and the way they should operate, to make sure that those are governed, and then to scale that. It's not a one-on-one. It's a tool that can be used at scale, and this allows standardization at scale, because the right way becomes the easy way, and that's how this works, right? If it's easy to do and it gets the job done, then the developers are going to use it, even if it's the right way, or especially because it's the right way. And then the proactive governance, because the platform engineering team is able to embed the security and the cost controls and the best, the standards and the best practices, etc. From the start, we can make sure that we're starting correct and keeping it correct, rather than having to come in and clean up afterwards. Let's do a time check here. Okay, I'm going to go through an example use case, but before I do, I'm going to take a quick look, see if there's any comments or questions. Looks like we're doing okay. Okay, let's talk about an example use case. And actually, it's more than an example use case. I work for Harness. This is actually what Harness did, how we evolved our infrastructure, and how that kind of led to what we're talking about. This happened around 2022, and we needed to make some changes. This is kind of that story. So we needed many new production environments. We needed to stamp out production 1, 2, 3, right? Things were exploding. Not physically exploding, but the business, Europe 2, etc. Right? And creating new environments was fairly manual. And when I say environments, I don't mean using IAC to spin up, and create a piece of infrastructure. I mean that and all of the other pieces of the stack around it, right? In conjunction with all of the continuous development and the rapid changes in the application that were going on. And it took a lot of money. I mean, it was costly to maintain this. The pre-production environments would often break. They weren't matching, or they had problems that one didn't match the other, didn't match production. And changes were being made by people in the pre-production environments, and then we would have finger pointing. The S-series changed it, the software team changed it, that's why it's broken, and so now my tests are no good, etc. I know that's not that's not very DevOpsy, right? But we needed to evolve from where the tools we had, and in different settings across environments cause problems and downtime. Oops. So what we set out was to create a solution. Harness Engineering created what we call dev spaces internally. And the notion was take infrastructure as code, that first piece, and add pipelines around it and logic and templates and all of the pieces that basically allow us to be consistent in the environments. And later we realized not just day 1, but day 2 as well, everything after creation. Right, and the goal was to make sure that this is why it's called dev spaces, that our developers could have an entire environment that matched production, so that each developer potentially, or each team, or each module or product could have their whole own version of Harness that they could work with, of production Harness, that they could work with and test against, as opposed to only having a piece or a stub, or not finding out until we got closer to production that there was problems. And this, of course, led us to easily be able as well to stamp out production environments that were cookie cutter and exactly matched for the whole application, as well as our integration, our testing, and everything else downstream as well. During this process, we found, okay, well, there's different groups that are concerned about different pieces of the puzzle, but they all need to be able to contribute to that, to what ends up being effectively the blueprint, and then eventually an environment that's running. Right, the cloud infrastructure level had, had identity management and VPC and whatnot that security was concerned about. FinOps had their say in as well, of course, of how much are we provisioning and are we doing, using the best resources for that, being efficient, etc. At the compute level, Kubernetes configuration, service mesh, things like that. This was the SREs. They had their notion of exactly how that should be. At the app and infrastructure level, databases, external secrets manager, etc. That was kind of split. Sometimes it was the SREs, depending on the team. It was the tech lead. So that was a little area where having at least one area defined where there might be that dichotomy was better than having it across everything. And then the applications, the business logic, right? The microservices. This was clearly the area of the developers, and the whole point here was to keep it isolated so the developers could get what they needed in a neat package from everything below and just focus on the business logic. And that's true all the way down the stack. So some of the key outcomes of the dev space's endeavor: each developer got their own testing environment for new features. As an example, John.pr, .harness, and visual and whatnot. The service and infrastructure configurations are all captured and automated and easy to change via Git. So not just GitOps, but all tracked together. The dev space, again, that's what we call them, configurations, were nearly identical to the production environments. And I say nearly because there might be like a difference in replicas, for example, but we could trust that when a team did the development and testing and validation on a dev space, that there was an extremely high likelihood that if there was a problem in production, it wasn't going to be because of a mismatched configuration or environment. It became easy to load a service version of production. So that became our baseline, pull it into a temporary environment or a special environment that's not production, and then override just the things that you want to change and test. And of course, being able to do this with a single click deployment is very valuable and freed up a lot of angst and waiting on tickets and back and forths. So this is what it looked like from a user journey perspective, right? The platform engineering team would create the workspace templates in our infrastructure as code management system. They would create the service definitions. These are the service and software and APIs and everything in the software catalog that define, the owner, the way to set it up, the scorecards to look at the standards and match the standards on what's good, what's in good shape for production and what's not, for example, of what's following security requirements and not. And then they would create the environment blueprint that brings this all together and defines the actions and activities and behaviors for the lifecycle management and all the rest of the pieces. So once a blueprint existed, or many existed for different types of environments, a developer who wants to create an environment for the work that they're doing would go through and find the environment that matches what they need. They would provide the environment configuration customizations that were identified in the blueprint, and then confirm those details. A policy check would be done automatically. If it didn't work, they would be sent back to make changes to their customizations. And then once the policy check's passed, it would be handed over to the orchestrator. And the orchestrator will look at all the pieces, figure out, for example, if we're in staging versus production and what configurations need to change on that. Look at the dependencies and figure out, for example, if we have Postgres and the backend, which one needs to be installed first. All of these little pieces, it would figure out the prioritization and the dependencies and all of that information, and then it would run the provisioning of the environment, of the infrastructure and the services together using your infrastructure as code management and your CD to do the deployment. And then it would wrap all that up and take the URL and put it back into the system so that the developer could just click on a link and get to that environment. Okay, before I go to that, so this is what we ended up doing and still do today. And this is actually, we were working with a customer, national bank, who asked, like, how do you guys do your cloud management and your environment management and development? And we showed them. And after we showed them kind of the stuff that I'm showing you, their comment was, we have to have that. Take my money, basically, right? And this begot a great partnership with this customer, where we worked very closely with them to make sure that this aligned with their expectations and their needs, and turned this internal capability into an external one. And that's the slide I accidentally pulled up first, which is what we call IDP environment management. So this is new. It is in beta still, but this is aligning to those ideals that we've been talking about. Some of the key capabilities that it has: the self-service golden paths for environment creation and day 2 operations. That's defined by the blueprints. The ability to orchestrate complex dependencies across infrastructure and services when we're deploying and getting an environment set up. It's oftentimes not just a simple serial placement of resources. And so that orchestration is necessary, highly. It is an extension of the IDP catalog, and that means that everything that gets created links back to the resources and services that were in the catalog already, that existed, and anything that's new gets put in the catalog. So that discovery is easy for developers and everyone else, working with all these resources. And it's easy to get metadata and dependency and linking and understand how everything comes together with all the details, including ownership and who to call, who's on call, what status quality everything is at, et cetera, including, you can pull in information about what PRs are open against, the services, et cetera. And so that all can stem from the environment where you're running your application. Of course, the ability to enforce security and governance guardrails we've been talking about with OPA, Open Policy Agent, Policy as Code, drift detection, and other things. And it is integrated as part of the Harness platform, which means that it gets the enterprise class and proven scalability and security, the policies, the auditability, all of the abilities, as well as today, Harness's continuous delivery and infrastructure as code management piece. Okay, with that, I will switch gears, and if you're still with me, I would like to show it to you. All right. So before I do that, while it's up here, I will take a quick look, see if there's any comments. Okay, a question we'll get to towards the end. All right, so what you're looking at is the environment manager, environment management part of our internal developer portal. Sorry, my double mirror of mouse movement is getting me thrown off. Okay, so this is part of, as mentioned, the entire developer portal piece, but it is cleanly integrated in so that anything you create here, for example, I mean, it is part of the catalog. ends up as part of the catalog environments, blueprints, for example. And these are the environments that are currently created and running or not running. And I can see those by my scope, right? So with Harness, we have an account level scope, an organizational level scope, and a project level scope, and you can use those in different ways. But what that means is I can see the environments that have been made available for me to see. Oftentimes those are my team environments. There may be more wider spread environments as well that are set up at an organizational level. So we have the environments. We have in here a few blueprints set up, and let's go ahead and create an environment using a blueprint. We'll take the sample app here, and you can see they can be cataloged out, and you can search through them and find them. And what this is going to do is start by saying, okay, let's collect some basic information. What do you want to call it? We're going to say that we're making an environment. Actually, I'll say I am making an environment that is for a particular maybe JIRA that we're fixing. The owner, I can put a description, I can put in tags, like maybe it's ephemeral, and define the lifecycle, production or experimental, and these are configurable as well. And then this is an important part, is the scope, right? And where we're setting the scope, I kind of started touching on that already. Is it account level, everybody can see it? Is it organizational level, and which organization can see it? Or is it project level? I'm going to put this at the project level. And what this means is my team that I'm working with on this project is able to get to these environments and operate in these environments. And this, one of the things this allows with the RBAC is to be able to work on, for example, a blueprint or an environment, and then share it later when it's ready. So we'll go ahead and have it configure the environment. And the next thing you're going to see is the blueprint on the right and the developer's interface, if they so choose, on the left. And what this is doing is this is saying, here are the variables that can be set for this environment definition. But first, if you remember back to that picture I showed, here's kind of the text version of it, right? The entities, we have the namespace, right? We have the Postgres database, we have the front end and the back end, right? And if we look at a little bit deeper, we can see that this is also where we're defining what is the behavior for create and apply and destroy and delete, if we want to define that. We also have the service definitions, right? The backend is a service definition, so it's pointing to the catalog, and we have default settings in there that can be overridden by the developer. Now, the other thing that we have in here is this piece. Where's this coming from? And this is as easy as it is to make this variable. This happens automatically. But for example, the workspace name, right, is right here. Oops, I can't. That's weird. So maybe I'm going to, call it my workspace, right? And then I can pick here, what are the, how many replicas do I want? What versions do I want? Maybe I want one, but my newest one, 1.6 that I want to test. And so that's great. I can take this blueprint and I can set it up the way I need it to then provision the environment for me. I don't have to interact with a whole bunch of tickets back and forth with 3 different teams that own different parts of this. Maybe there are 4, right? It's all here. And when I'm ready, I say create environment and it goes off and does it. However, and I will do that in a minute, but however, it's also possible and actually more likely that there's an environment that our team is using that we got all configured, right? Now this one is a short one. It's only got a couple of things in here, but a lot of environments could have 10 resources or 5 resources and 10 services or something, a lot more in it. And so having to do that configuration every time is pretty laborious. Instead, I can go to our known, our environment with known good settings. Maybe it's the QA environment or someone else's environment. Let's say it's the QA one. And that will pull all of those settings forward. And then I can make my changes from there. Like maybe I want 1.6 still. And at that point, I can say create environment. And just that quickly, I basically replicated an environment, like maybe it's production, or maybe it's our key environment that we've been testing in together, and made my change so that my change is what I'm going to be testing and working with. Now, this is going to go kick off the pipeline in the background and start processing all of this. You can see the resources are underway, and the components will come shortly after. I can always get straight to the details. I don't have to. One click away. And this is the pipeline that's running in the background as we speak. And I can click in and get more details about it, including like the logs and everything else. So really easy to get access to all that, but I don't need to. This will just go do its thing. And when it's ready to go, then I can jump in and start using it. Now, if I go back to here, you notice there were defaults that it came with, right? And think about what we just saw here, right? I created an entire environment. Maybe it's a complex production setup with a few changes and a few clicks. Now, could you imagine if a developer had to do this by going through and editing the Terraform, the raw Terraform, and then figuring out, what are the permissible values, right? Sky's the limit, right? It can change anything. Every PR change that's put in has to be reviewed by somebody, right? Because we don't have any guidelines or guardrails. What's the change going to do? Is it even something they can do that are allowed to do, right? If we're editing direct the processes, the code that's doing the infrastructure provisioning, for example, and the deployment, then it's not locked down, and we don't have this simple an interface. Whereas a developer, I can do a huge lift of creating an environment in very simple, with a few simple steps. So this is the area where platform engineers are going to get to define the limitations and the values that are default and okay to use, and even what can be changed. Right, so those are the guardrails, in addition to the policies and everything else that are part of the pipelines. Check time. Good. So we've got the environment already going. So let me pop back over there. It looks like it's mostly done here. There we go. So these components are the ones in the software catalog. So we can go into the software catalog and get all of the details that's stored about the components, because we may have just provisioned it, but it is relating back to a software catalog piece that has information about the account user, an owner, the source, the documentation, etc. This one's a little bit bare, but all that information would be there, including the scorecards and how it's doing as far as meeting our requirements for something that may go production, for example. Same thing with the resources. Let's do Postgres. I can go and get directly to the information about how the provisioning happened. In this case, it was Terraform, actually Terraform. I can see, if I wait a minute, that's interesting. Usually the information, there we go. So it's still coming through, but the history of that creation. Oh, it's still going, that's why. Jumped the gun a little bit there, so let's look at the other one. Right, so I can go get all the details, about that resource and its provisioning and its history and all of that right at my fingertips. So for troubleshooting, very good. Now the other piece of this, and we'll go away from this and that's going, is that's creation, right? We talked about creation, but we really talked about the importance of day 2, right? Now, day 2 can be a lot of things. I showed you how I can go look at more details about the environment, right? Or about the resources and about the services. But we might also want to do other day 2 things for sure. For example, I'll go to this environment. For example, I might want to make a simple change, right? And instead of having to reprovision everything, maybe I want this to, I'm going to put this back to 1.6 because this last version not so good, right? That was update environment. You'll notice it wasn't create environment because environment already exists. Now what you see is happening is it's only doing the piece that it needs to for updating the instance, the backend that I changed. It's not touching anything else. And it has a definition of how it needs to do that, whether or not there's dependencies it needs to deal with, etc. This makes it really simple for me to work with the environment and make changes to it. And the key here is that if you were doing all of this management with scripts or just simple serial workflows or pipelines, you really couldn't do that because one of the key things that has to happen is we need to know the state of things. We need to keep track of where things are at, and we need to understand how to make changes to them without breaking them. And so I'm able to do that. It's already done. I made that one change. Now, what if I make a change? We'll put it back the other way. And then at the same time, somebody else, because we have shared environments, right? Not everyone gets their own environment all the time, but maybe another developer I'm playing here will make a replica change, for example, right? We used to have to get onto Slack and say, okay, is anybody making a change on this environment? Or please don't do X, Y, Z. And we are adding locking into this as well. But right now I can see right away that there's 2 changes going on, 2 pipelines that are running and changing different things. I can get again to those pipelines and see the details if I need to. Just kicked it off, so it's just getting going. But as you saw before, I can see the all the details of what's processing and how long it's taking and what the inputs are and all of that. And eventually, all those changes will get done. There we go. And so I can do this without wondering, is anybody using this, right? Is anybody going to cause, running on this system as well? And then I can also see that information by looking at all the activities, so I can know who's touched this or who's done work on it and get information about what details very easily. So the last thing, before we run out of time, that I'd like to show you is we talked about the real big value of drift detection, right? That's not the one I wanted. And here's an example of an environment where one of the types of drift detection is kicking in. You'll notice what it says is, hey, the blueprint changed, right? So drift detection can look at multiple things. If a blueprint that an environment is based on changes, we will flag it, right? The PE team, the platform engineering team, may decide that they want to just force push it because it's like a critical security issue and they'll deal with the repercussions. Or maybe they've already done some testing and validated with everyone. But it can also be that, again, they push the change into the blueprint and then everyone gets flagged like this that says, hey, there's a change. And then editing the config and having it go through and fixing those changes is really all I need to do. But there could be a different thing that happens, right? The infrastructure could have gotten changes. We might have drift at the infrastructure, at the IAC level. If Terraform, for example, says one thing, but the actual infrastructure is different, then we'll surface that here, as well as services drift, right? If we installed one version and somebody else manually changed it, deployed a different version, that'll get flagged here as well. And that's going to help us avoid having the drift problem and always making sure that our environment's aligned to our blueprints and the changes that have been made properly in the system that we're tracking. Okay, so that is kind of there's so much to show here, but that's a quick overview of some of the capabilities that we're working on building out and the value that it can add to a development team, a platform engineering team, et cetera, pulling all those pieces together. So I'm going to switch to Q&A. Oh, did I miss doing that? Okay, well, there was that. Thank you, first of all, for your time. Let me take a look at the Q&A. While I'm doing that, Okay, there's a few in here. There's two things on the screen here. If you want to learn more about the internal developer portal from Harness and the environment management piece of it that we just looked at, this QR code will take you to some of that information. You can talk to some of our folks. And then there's a conference going on. There's one in San Francisco today, and there's also a virtual version of it that's coming up on the 30th, where we talk about the industry around how AI and software delivery are coming together. It's basically our user conference, but it's also really a conference where we're bringing in customers and different folks in the industry and having just an open discussion about how we move forward together and do better, do faster. All right, so if we can leave that up, and then we'll take a look at the questions. Okay, so you said that the blueprint is more than just a template. Yes. How are they different? Can you give a practical example? Okay, yeah, sure. So they gave an example here. For instance, does a blueprint prevent a developer from using an overly expensive instance type or a non-compliant configuration? Absolutely. You can define, so part of the blueprint is you're defining the workflow and hence the pipeline, the workflow being the facade collecting the info, and the pipeline behind it that actually does the execution that goes out and talks to everything. But before it does that execution, it has policy as code that can be enacted to make sure that the inputs are acceptable inputs. So that's one example. Let's see. Why can't I just do this with IDP workflows or any workflows for that matter in Terraform? We did start there. I think there's no state collected, and so really what happens is you can get that day one piece where you create the environments, but going back and knowing where things are at, not just what's recorded, from the deployment time or provisioning time, but what's happened every step along the way. In other words, an environment is a living thing, and we need to be able to track it and understand its state changes along the way, so that when we want to go in and do those day two tasks, we're able to do that with confidence and cleanly. And that includes also the blueprint, including the behavior, the activity, how it does those lifecycle items. And then it's looking like this uses Harness IAC tools, we call infrastructure as code management, and CD pipelines, which is true. Does this also work with third-party tools? So at this point, and keep in mind we are just in beta here, it is just with Harness's tools, Harness IDP, the Harness platform, CD, and IACM. However, we are planning absolutely, and once we get it out, to have it work with other infrastructure as code management, as well as other CD pipelines. So that is coming. All right, check the chat real quick. Okay, it looks like we're out of time. Thank you very much, everyone, for your attention. I hope that was that you found some useful information, and do please feel free to contact us so we can keep up the conversation. Thank you much.